Okay, so why do we learn to write chemical formulas? Because if we know how to write chemical formulas, there's all sorts of really cool things that we can do with math. Yes, math. This chapter is called The Mathematics of Chemical Formulas. So the first thing, and I warned you that there were some things that we were going to deal with this 9 weeks that was going to be tough. That was going to make it the toughest 9 weeks of the year. But this ain't one of them. Okay? So today, what we need to do is if I give you a chemical formula or a chemical name, can you write the formula mass? Can you determine the formula mass for me? Yes. I just. Okay, so now that we know how to write chemical formulas, what do we do with them? Of course, we can identify stuff for us, but it can also help us to use math. Yes, math. So what can the math help us do? It helps us to be able to predict how much stuff we can make and when we know how much stuff we need to start with. Not really practical for you, but really practical for chemists and chemical engineers and chefs, which can be thought of as chemists. Actually, there is a branch of chemistry called food chemistry. One time I had a student whose dad was a food chemist, and he came and he uh, he made food for us. He did. He made food for us, and that was really the best pork chops I've ever had. And he got oranges, and he got the he zest. Yes. And but the really cool thing is he explained to us the chemistry behind this. And yeah, any new food that you see on the menu, a lot of people had their hand in it in order to provide for us what they thought that most people would like. Yes. Yes. Chefs? How? With the help of our best friend, we can convert a chemical formula into a number. How? Look at your bestie. Look at your bestie. See how every element has a number underneath it? That number is the weighted atomic average. That is the weight of all the isotopes taken into consideration. They are the relative atomic masses. Think of it as a price list. That is what the element is worth. So, what is formula mass? The mass that one molecule, or Fu, has. The mass that one molecule, or Fu, has. Now, if you're wondering, why does he keep cussing? I am not cussing at you. Fu stands for formula unit. It is the smallest particle of an ionic compound. A molecule is the smallest particle of a molecular compound. There are two kinds of compounds, molecular and ionic, and we have different words to describe their smallest particle. Molecular, molecule. Ionic, Fu. So, how do you determine formula mass? You add up the masses of the individual atoms that make up the formula. It's kind of like going to the checkout counter at a store. When you go to a checkout counter, there are some things like some fruits, especially fruit, that do not have a SKU, a barcode. Okay? So the checkout person has to usually look on a sheet of paper. The sheet of paper will have some kind of code for bananas or apples or something. And then they put in that code, and the computer knows how much it costs per weight. So, this is something you're familiar with. You go to a candy store, you get a bunch of candies at one time in a bag. They don't sell it to you by the candy, they sell it to you by the weight. They sell it to you by the weight. So they usually have a chart, some kind of sheet of paper that tells them how to ring it up. So, how easy is this? Easy. You ready? I'll do the first one and then I'll call on volunteers. And what I mean by volunteers, they're usually people who are trying to hide from me. All right, so what do? You break it up into its parts. 1 potassium, 1 nitrogen, 3 oxygens. Then you look up on the periodic table what they're worth. 1 potassium is 39.1. 1 decimal place, please. 1 decimal place. What if your answer is not in 1 decimal place? It's wrong. Nitrogen, 14.0. 3 oxygens at a price of 16.0. So 1 times 39.1, 39.1. 1 times 14, 14. 3 times 16, 48.0. 1 plus 0 and 0 is 1. 9 and 4 is 13, and 8 is 21, maybe. 2, 5, 6, 10. 101.1 U. We cannot use grams. Grams is, these particles are so small that grams is meaningless to us. Actually, grams would be a number to the negative 24th, I believe. So that is not meaningful to us. So we came up with a unit for expressing atomic mass. So we call it the atomic mass unit, which kind of makes sense. Or AMU for short. Or if you're really, really lazy, U is short for AMU, which is short for atomic mass unit, which is short for the unit that we will use to measure these things, because gram is too big a unit. Wow. You've seen some hard stuff. This ain't one of them, is it? All right. Here we go. Malachi, thank you for volunteering. How many irons? At a price of? One times 55.8 is what? Ray, how many oxygens? Very good. She used the distributive property. That 3 outside means it's the same thing as saying this. She is correct. Distribute the 3 outside with what's inside. 3 oxygens at a price of 16.0. 3 times 16. Guys, calculators, have them out, have them handy, have them warmed up and ready to roll. Buttocks up, walk. Yes. We break it down per element using the distributive property. All right, so Canaan, how many hydrogens? 3 hydrogens at a price of 3 times 1.0, 0.0. All right, Christiane, what is your answer once you have 55.8, 48.0, and 3.0? Is that your final answer? No, because we don't like naked things here. We have to have a unit. Oh, I'm sorry, I didn't hear you. 106.8. If you do not have the letter U there, I will consider you somebody that likes to look at naked numbers. And we don't like naked numbers here. We have to have a unit, even if the unit is U. Continuing on. Elaine, how many nitrogens do we have in this formula? At a price of, for a total, I'm literally getting older. All right, Zach, how many oxygens? 4 at a price of 4 times 16. 28 plus 64. So 28 plus 64 is 68? That was not Zach Lang. That was not him who came up with that. I wanted to make sure that they realized that it wasn't Zach Lang that added 28 and 64 and came up with 68. Okay, it wasn't Zach Lang. I'm not going to say his last name, but it wasn't Zach Lang. All right. Any question? Is that your final answer? Is that your final answer? Me what? All right. Emma, how many HGs? At a price of? For a total of? 400.12? 401.2. All right. Sierra, how many nitrogens? What? Where'd you get the 3 from? This 3 right here, that's referring to oxygens. Yes, distributed property, 2 nitrogens. Sierra, price? Periodic table. Two times 14.0. 28.0. All right. Macmillan. How many oxygens? It's something Mac, isn't it? McMurtry, McMahon. I thought I said Macmillan. Go, Macmillan. Very good. That was very nice. 2 times 3 is at a price of 16 times 6. $96 plus 401.2 plus 28. What is it? Is that your final answer? Me? Okay. Any questions so far? So how did they come up with these numbers anyway? Well, every element has flavors. We call those flavors isotopes, and we're going to end it right there. That's tomorrow's stuff.